So imagine just pasting your company's most tightly guarded proprietary source code directly into a browser window, just sending it off to some server farm out in California.
Oh, I mean, for most developers listening to this, that is an immediate fireable offense.
Right, like instantly fired. But we are so conditioned to rely on cloud-based AI, right?
Yeah.
We're just sending our prompts, our data, our private thoughts out into the void.
Yeah, we just accept the risk. Or we just, don't use AI for the sensitive stuff.
Exactly. But what if that massive AI brain wasn't on a server farm? What if it was sitting completely offline, running securely, like right there on your laptop?
It fundamentally changes the entire equation. I mean, we were talking about a shift from renting intelligence to actually owning the infrastructure it runs on.
Which is huge.
It is. When you run an AI locally, you aren't just gaining privacy, you are changing your entire relationship with the technology. But, shifting away from the cloud means you suddenly have to grapple with the limitations of your own hardware.
Which is actually the core mission for today's deep dive.
Yeah.
We're looking at a stack of sources today covering an open source tool called Ollama.
Right.
And we really want to figure out if running powerful large language models, or LLMs, locally on your own machine is actually practical right now.
Because if it is, that's massive.
Yeah, exactly. Because if we can sidestep the cloud entirely, we're looking at a game changer for anyone who needs absolute data security and is, frankly, just tired of posts per token fees.
And spoiler alert, it is incredibly practical today, but really only because tools like this have finally abstracted away the massive technical hurdles that used to make local AI a total nightmare.
Oh, for sure.
But to really understand the impact, we first have to separate the model itself from the mechanism running it.
Okay, I see where you're going with this.
Yeah.
We need to clear up the central misconception right out of the gate, because the sources emphasize this immediately. Ollama is... it's not an AI model itself.
Right. So
You aren't opening a terminal and chatting with Ollama.
yeah.
It is a runtime and a package manager.
That distinction is so vital. Like when you log into a service like ChatGPT, the web interface, the servers, the underlying neural network, all of that is packaged as a single opaque product.
You just type in, it answers.
Exactly. But in the open source ecosystem, a model like Llama 3 or Mixtral is just a massive mathematical file. It contains billions of parameters. It's essentially just gigabytes of weights and biases.
Just sitting there.
Yeah, just sitting there. A file like that does nothing on its own. You need a highly specialized piece of software to load those numbers into your computer's memory and execute the math.
So the analogy that jumps out at me here is a video game console. Or maybe like the Steam platform on a PC.
Oh, I like that.
Right. Because Steam itself isn't a video game. It's the launcher. It manages your library. It handles those painful updates. It figures out where the files actually belong on your hard drive.
Right, right.
The games are the open source models you download. So Ollama is the platform that makes playing those games incredibly easy without having to build the console from scratch every single time.
That captures the user experience perfectly. And to appreciate why that user experience is so revolutionary, just consider what the before Llama era looked like for a developer.
Oh, man.
Say you wanted to run an open source model locally just a year or two ago. You would download this massive file from a repository like Hugging Face. Then you had to set up a manual Python virtual environment.
Fun.
Yeah. You had to make sure your version of PyTorch matched exactly with your specific hardware architecture.
And inevitably, the CUDA drivers for your graphics card would be the wrong version.
Always. Every single time. You would spend 3 hours debugging dependency mismatches, wrestling with graphics card drivers, and trying to decipher cryptic memory allocation errors just to get the model to say, hello, world.
It was prohibitive.
Yeah.
For anyone who wasn't a dedicated machine learning engineer.
Completely.
So how does Ollama actually bypass all of that? Because looking at the sources, getting started now is as simple as opening a command line interface and typing Ollama run Llama 3.
Literally just that one command.
Yeah. You hit enter, and you are immediately in an interactive chat. What is actually happening in those few seconds under the hood?
So it executes this very elegant 3-step orchestration process in the background. First, it reaches out to its registry to fetch the exact model weights and configuration files.
Right.
It handles the downloading, the versioning, and the file verification, ensuring you don't get a corrupted multi-gigabyte file.
So no more hunting for the right download link on some random forum.
Precisely. Step 2 is where it solves that dependency nightmare we just talked about. It sets up an isolated, containerized environment for that specific specific model.
Oh, I see.
It automatically bundles the necessary execution libraries. You don't install PyTorch. You don't touch your system's CUDA drivers. It abstracts the environment completely.
And the third step?
The third step is the execution itself. Ollama compiles the runtime using highly optimized frameworks, specifically things like llama.cpp and gguf formats, dynamically allocating the workload between your system's CPU and GPU.
Just maximizing the inference speed. And it's not just Llama 3, right?
Yeah.
You can fire up models like Mixtral or Phi-2 or DeepSeek-Coder just as easily.
Yeah, just change the name in the command, Ollama, run Mixtral, boom, you're running Mixtral.
Okay, wait. I want to pause on that dynamic allocation, though, because if I just type a terminal command and get an AI, why would I just keep using the cloud? The cloud already abstracts the hardware for me.
That's a fair question.
We talked about the privacy angle a little bit earlier, but let's really drill down into the data flow, because that's the real thematic shift here.
Yeah, the data flow is the primary driver for enterprise adoption of local models right now. With a cloud API, every single keystroke of your prompt, the entire context window, any documents you attach, all of it is serialized and transmitted over the public internet to a third-party server.
Right.
And even if the provider promises they don't train on your data, you are fundamentally trusting an external infrastructure with your proprietary information.
Which brings us back to my example of the source code at the very beginning. If I am building an internal tool to analyze my company's code base, or say I work in healthcare and I'm parsing patient records, external API calls are just a complete non-starter.
Oh, absolutely. Compliance departments will shut that down instantly.
But with Ollama, you're saying the execution stays on the local bus.
Entirely. There are 0 external API calls during inference. The model sits in your local memory. The prompt is processed on your local silicon. The output is generated locally.
So it's a completely closed loop.
Exactly. From a network security perspective, you could physically unplug your machine from the internet, and the AI would continue to function with 0 degradation.
That is wild.
The data governance changes entirely when the processing is brought directly to where the data resides, rather than shipping the data off to the processing power.
That offline capability is huge. But, I know a lot of developers who don't necessarily deal with classified data, and they are still running to local models.
Oh, sure.
And reading through these sources, the other massive incentive is the economics.
Yeah.
Like we were talking about the end of per token fees.
Yeah, the mental friction of cloud APIs really cannot be overstated. When you build an application powered by an external LLM, you are trapped in an operating expense model. You pay a fraction of a cent for every word you send and every word the model generates.
Which sounds negligible, right? Until you start running massive data sets.
It adds up so fast.
Like, I have a friend who built a script to summarize thousands of PDF documents for a research project. He ran it through a commercial API, went to sleep, and woke up to a $500 bill.
Oh no, because of a bug.
Yep, he had a bug that caused it to loop. It is literally a running meter.
Yeah.
You sit there and watch your bank account drain in real time as the text generates.
And then anxiety changes how you develop. You hesitate to experiment. You write overly complex logic to minimize the size of your prompts just to save, fractions of a penny. Ollama flips that economic model on its head entirely. You transition from an unpredictable operating expense to a fixed capital expense. Once you own the hardware, whether it's the laptop sitting on your desk or a server rack in your closet, inference is essentially free, minus the cost of electricity.
You can run millions of tokens through a local instance of Mixtral all weekend long, testing edge cases, failing repeatedly, and your bill is exactly $0.
Zero.
The freedom to experiment without a financial penalty is just a massive catalyst for innovation.
It is a profound shift, but, we do need to maintain a grounded perspective here.
The reality check.
Yeah, we can't pretend that running an AI on a consumer laptop is identical to running it on a $100 million server cluster. We have to examine the hardware reality.
I figured we'd get to the catch eventually. We are physically constrained by the silicon on our desks.
Consider the scalability problem. Cloud-based LLMs are highly elastic. If your application suddenly spikes from 10 users to 10,000 users, the cloud provider's load balancers just automatically spin up more virtual machines to handle the traffic.
Right, they just throw more hardware at it.
Exactly. Your local machine cannot horizontally scale like that. You are strictly bottlenecked by your available RAM and the computing power of your specific GPU.
Hold on, though. I think we're selling local hardware short here if we only look at raw compute power and user scaling.
How so?
Well, sure, my laptop isn't going to serve 10,000 concurrent users, but for a single developer or a small internal tool, local execution actually has a massive advantage over the cloud, and that is latency.
Ah, right. Let's explore the mechanics of that.
Because when I send a prompt to a cloud AI, no matter how fast that data center processes the request, the data still has to actually travel across the internet.
The physical distance.
Yeah. It has to route through ISPs, hit the server, get processed, and travel all the way back. There's an unavoidable network round trip. Sometimes that takes a full second or more just to establish the connection.
It's true.
But with Ollama, my data doesn't have to travel to Virginia or Oregon.
Yeah.
It just travels an inch across my motherboard.
That is a critical distinction. The time to first token, which is the moment the AI actually starts typing its response, can often be significantly faster locally because the network latency is effectively zero.
Right.
Now, your overall throughput, meaning how many words it spits out per second, will definitely be lower than a data center, but the system feels instantly responsive.
Which is vital if you are building an interactive tool.
Right.
But wait, I want to understand how it's even possible to run these things locally without a supercomputer.
It's a great question.
Because the models we are talking about are billions of parameters. They're huge. How is Ollama cramming a brain that size into the RAM of a standard MacBook?
That is where the underlying engineering becomes truly fascinating. Ollama leverages a highly optimized backend framework called llama.cpp.
Okay.
The CPP stands for C++. It bypasses the bloated, heavy Python ecosystem entirely and runs incredibly close to the bare metal of your machine. But the real magic is a technique called quantization.
Okay. Break down quantization for me. How does that work?
So think of a neural network as a massive spreadsheet with billions of cells, where each cell contains a highly precise decimal number, a weight. Normally, these are stored as 16-bit floating point numbers.
Right. Standard precision.
Storing billions of 16-bit numbers requires an immense amount of video RAM, usually way more than a consumer graphics card actually possesses.
So you'd need massive enterprise GPUs just to hold the model in memory.
Exactly what used to be required. But quantization is essentially a compression technique. It mathematically rounds those highly precise 16-bit decimals down to much smaller 8-bit or even 4-bit integers, often using a file format known as GGUF.
Wait, doesn't chopping off all that mathematical precision make the AI dumber?
You would think so, but that is the counterintuitive brilliance of modern neural networks. They are remarkably resilient.
Really?
Yeah. Researchers discovered that you can compress the model's precision massively, shrinking the file size from, say, 16 gigabytes down to just 4 gigabytes, with only a negligible loss in the quality of the actual reasoning.
That's incredible.
By using the GGUF format to load these quantized, compressed models, Ollama allows a 7 billion parameter model to sit comfortably inside the standard 8 gigabytes of unified memory on a normal consumer laptop.
So they're basically shrinking the brain just enough to fit in the skull of a laptop, but it still retains almost all of its knowledge. That's a great way to put it. That explains the hardware miracle.
Yeah.
And having that brain on your local machine unlocks another feature the sources highlight, which is absolute control over customization.
Yes.
Because we aren't stuck with the generic personality of the AI.
You are referring to model files?
Yes. If Ollama is like Steam, a model file is like downloading a community mod for your game. But the technical implementation is what I find so clever here.
Walk us through how a developer actually implements one.
Well, it functions incredibly similarly to a Docker file. If you are familiar with containerization, you just create a simple text file. You define your base model, let's say from Llama 3.
Okay.
Then, instead of duplicating gigabytes of data to create a new model, you just layer instructions on top of it. You can set the temperature to make it more creative or more analytical. You can hard code a massive system prompt that says, like, you are an expert Python debugger only replying code snippets.
And because it is just a lightweight text file, you can version control it in Git. You can share it with your team. You boot up your custom mod instantly, and Ollama applies your specific parameters to the underlying base model dynamically at runtime.
It's just elegant.
It avoids the massive storage overhead of fine-tuning a completely separate model.
But this brings us to arguably the most important question for our listeners. We understand the privacy, the zero cost, the hardware tricks, and the customization. But how do you actually build an application with this?
Right. Beyond the terminal.
Yeah, if I don't want to just chat in a black terminal window, how do I connect my actual software to Ollama?
This is where Ollama crosses the line from being a neat local toy to a piece of actual production infrastructure. It runs as a background service and exposes a local REST API.
Okay, web endpoints.
Exactly. It opens up local endpoints, specifically things like Puest Apigenerate.
And this is the absolute aha moment for me in these sources. The architectural choice they made here is brilliant. They didn't just build an API, they built an API that is functionally a drop-in replacement for OpenAI's API.
The implications of that design choice are just massive for the developer ecosystem. Explain how that swap actually looks in the code.
So, say you have already built a Python application or maybe a Node.js backend that relies on ChatGPT. You have the official OpenAI software library installed. All you have to do is find the line of code that sets the base URL, which normally points to OpenAI servers, and change it to point to your local machine. Usually something like localhost.11434.
That is it.
Literally one line of code. Your application doesn't even know it isn't talking to ChatGPT. It sends the exact same data structure, but Ollama catches it locally, processes it using Llama 3 or Mistral, and sends the response back in the exact format the application expects.
It achieves total vendor lock-in avoidance. By ensuring that API compatibility, it allows developers to build out massive, complex application architectures without being financially tethered to a specific cloud provider.
Which leads us to the two most powerful use cases we are seeing in the industry right now. The first one has to be prototyping, the ability to fail fast.
Without question. Imagine you are building an AI agent that requires analyzing massive troves of unstructured data. You might need to run tens of thousands of test prompts just to refine your logic. Doing that in the cloud during the development phase is financially punishing. But with Ollama, you point your local environment to an open source model. You run your massive test suites over the weekend, you refine your prompt engineering, and you do it all for $0.
That's amazing.
You only switch the API URL back to a paid cloud provider when you deploy the final application to production. And really, only if the local model wasn't powerful enough for the final task.
The second major use case takes that a step further, where you just never switch to the cloud at all. Edge AI.
Yes. Deploying robust intelligence to environments where a constant internet connection is either impossible or a massive security risk.
Think about software designed for remote research stations or tools built for offshore oil rigs. Or, on a more everyday level, imagine you are a developer building a personal journaling app.
Okay.
You want it to analyze a user's deeply personal diary entries and offer psychological insights. If you build that relying on an external API, users have to trust you and your cloud provider with their most intimate thoughts.
Which is a tough sell. But if you package Ollama alongside your application, the analysis happens natively on the user's laptop, even while they are on an airplane with no Wi-Fi.
Exactly.
It allows developers to build highly capable, deeply personal software with a guarantee of absolute privacy.
So, to bring all of this together, Ollama isn't the brain itself. It is the incredibly efficient nervous system that makes running the brain locally effortless.
Perfect summary.
By abstracting away the nightmare of dependencies and leveraging quantization to squeeze massive models onto consumer hardware, it just unlocks a whole new paradigm.
It really is.
You get absolute data privacy because nothing leaves your motherboard.
Yeah.
You eliminate the anxiety of per-token API bills entirely. And with drop-in API compatibility, you can transition your existing applications to run completely offline with literally just a single line of code.
It is a profound democratization of infrastructure. I mean, we are moving from a computing era where cutting-edge AI was exclusively locked behind the paywalls of massive server farms to an era where that intelligence is a decentralized utility, running securely on the silicon already sitting on your desk.
And that reality leaves me with a final thought for you to mull over. We have spent the last few years assuming that the future of computing would be entirely centralized in the cloud, relying on massive tech conglomerates to process our digital lives.
Right.
But if tools like Ollama continue to refine local execution and open source models continue to shrink in size while growing in reasoning power will, relying on massive, expensive, cloud-based AI soon become the exception rather than the default for everyday development.
That is a fascinating question to leave us on.
Something to explore on your own. Thanks for joining us on this deep dive.